Good afternoon. Thank you for this great opportunity to give you the presentation of our scientific report on the theme of sustainable healthcare technology for a broader future. What we're going to present is robotic rehabilitation exoskeleton for hemiparetic gait with torque, phase, and angle motion control of gait cycle in pandemic era. For our presentation, first of all, let me introduce myself and my team members. My name is Michelle Optrikartika as a second member of PBLAC team. There is Brian Johannes Renaldi as a team leader, plus Valenta Veronica as the first member, and last but not least, our academic advisor, Mr. Akif Rahmatillah, Bachelor of Engineering, Master of Engineering from Erlangga University. So before that, in the beginning, we have to know about human gait. Human gait is a complex control interaction of the nervous and musculoskeletal system. In fact, the speed and the gait of older adults are sensitive markers of general health and survival. For some conditions, there are differences that appears in the human gait cycle, which we call gait disorders. Gait disorders are associated with increased morbidity, mortality, and decreased level of function. These disorders cause loss of personal freedom, falls, injury, and result in a marked reduction in quality of life. Gait disorders can be caused by disorders of the nervous system, one of which is a stroke. Based on global stroke data from the World Stroke Organization, it can be seen how stroke accounts so many deaths and the loss of millions of years of healthy living due to disability. Research has stated that stroke is one of the leading causes of severe long-term disability. Disability experienced by post-stroke patients in the form of hyperextension of the knee, causing hemiparetic disorders up to 68% of the patients. This disability occurs at a very high prevalence in stroke patients who experience a neurological disorders, sensory motor, which require rehabilitation to regain the function of their body. In these cases of hemiparetic gait, patients need two main types of treatment in the form of physical therapy, which can provide training that triggers the nervous system, and neurological rehabilitation that aim to reduce disability for the future self-care and daily activities of stroke survivors. However, there is a problem which states that physical therapy and rehabilitation are necessary but cannot be assessed during the pandemic COVID-19.
Yet we all know the problem here. We have seen what the COVID-19 pandemic has done to everyone all around the world, but not only just the COVID-19 pandemic, also the potential of more pandemics to come, just as what has happened before. In pandemics, sadly, rehabilitation is scarcely offered, mainly because of diseases causing pandemic are usually easily contagious. This problem results in hindering patients' recovery, also prolonging immobility, leading to significant functional impairment. But Chen Chi Wang in 2020 gives us a shred of hope, saying that potential techniques and specialized rehabilitation tools can restore nerves and maintain muscle strength. Yes, bridging technology with the problems of medicine that we have today give us a wider scope to a solution of what we can do regarding our problems, especially here regarding gait cycle rehabilitation, which is why we from Bebelac provide to you our solution that is ROREX, robotic rehabilitation exoskeleton with torque, phase, and angle motion control of gait cycle. ROREX, using repetitive controls and intensive training, helps rehabilitation with what is needed before. Rehabilitation before needs direct human contact with clinical staff, but this time with ROREX, we reduce that, reducing the use of movement and energy that is needed in rehabilitation, especially in this pandemic. Our workflow research is as thus. First, we study what we need so we can know what we are facing. Next, we simulate our program through Proteus and Arduino Uno and other tools. We also make our DC motor direction control system with Arduino Uno and H-Bridge. Next, we manufacture our robotic exoskeleton with two simulations that are torque control and gait cycle simulation. And we take what we have gotten through our research, we analyze the results so we can know how well in numbers does ROREX actually assist gait cycle cycle rehabilitation. We hope from ROREX that we can provide functional movement training adaptable to the patient's gait cycle condition. We also have that ROREX can reactivate sensory and central neuron abilities to help with rehabilitation. We also hope that ROREX detect the foot's movement and help the leg muscles to step slowly according to where the patient is moving them. And with ROREX, with its adjustable stepping speed and angle movement, we hope that we do not over-access rehabilitation and overwhelm the patient's muscles, but we can give them rehabilitation according to what they need until their gait stability can return back to normal.
So before we continue to the result of the simulation, first I'll explain about the device workflow concept and the function of main electrical circuit component in this simulation. The first one is strange gauge or load DC, which is the sensor that detects the direction and the magnitude of the torque from the user's footwork. And then to the Arduino Uno, which is microcontroller that used for sensor reading, data conversion, and exoskeleton control. And then to the program in Arduino Uno, which is the instruction that given to process data and control the exoskeleton motor's output. And then to the output of exoskeleton, which is the motor, where motor's rotation is according to the direction and the amount of torque and sensor. And on the left side, we can see there is an H-bridge circuit. H-bridge is a circuit that uses a power driver in the form of transistor to control the direction of DC motor rotation to the positive or negative direction. The first system is torque control for robotic exoskeleton, which has the advantage of controlling the direction of torque and reading the magnitude of the torque more specific, where in the system, we set the op-amp only to allow motor rotation if the leg torque is in the minimum torque of 5 kg-meters. It takes a minimum of 5 kg-meters on the positive load cell to move the motor to the positive direction, and a minimum of 5 kg-meters on the negative load cell to move the motor to the negative direction. Suppose the reading value is below 5 kg-meters. In that case, the motor is in a stationary position, which is 0 kg-meters torque. So the patient can rest without performing a continuous walking simulation on a gait simulation exoskeleton. The second system is the walking simulation with 3 motors for exoskeleton, which train the patient to walk according to gait cycle. In the lower extremity exoskeleton, there are 3 points of gait cycle joints that are important to note in walking simulation: the hip, knee, and ankle joints. In the second simulation, the servo motors rotation is carried out by coding the position of the angle and phase delay to form an angle and phase timing that is close to the phase and angle requirements of the gait cycle on the leg. This is the visual representation of walking simulation with phase angle for robotic exoskeleton, and the left side is the graphic for the hip angle degree, knee angle degree, and the ankle angle degree. This is the leg angles at 0% phase. This is the 15% phase, 37% phase, 50% phase, 66% phase, 88% phase. And the result become like this. Then the result of the walking simulation is compared to the reference normal gait by Stephanie Arman, which is the title is normal gait. The accuracy result of this simulation for the hip joint is 95.353%. For the knee joint is 93.545%. For the ankle joint, 95.132%. So the overall simulation accuracy average for the simulation is 95.029%.
In conclusion, we are happy to state that ROREX can assist post-stroke patients in gait rehabilitation by providing a robotic exoskeleton, which motor movements are triggered by its patient's leg movements detected by the strain gauge. Also, the simulation that we have conducted shows that ROREX has achieved an accuracy of 95.029% in accordance to human gait. We hope that ROREX can broaden solutions for gait rehabilitation. We are Bebelak from Unifest Ailanga. Pardon us for any imperfections. Thank you for listening.